Open source data integration, our experience started in 2007. We were working on a point of sale software deployment. It was a Fortune 500 retailer in Columbus, Ohio. And one of the problems they had was just getting access to the data in a timely manner. You had to wait for this process called the end of day process to post the sales up to the central office. And that's when they could actually reconcile and audit sales and know how they did for the day. Another problem was we had to deploy to 1,200 stores. And by the time we'd gotten up to about 300, we started to get these failures during the end of day publishing. Using like a JMS publish feature, it would go to the dead letter queue. We'd have to get up in the middle of the night, or we'd have to fix it first thing in the morning. So it was kind of a support headache. Another problem was the sales were stored in the database, and we wanted to customize the sales. Every retailer's got something specific that they do that makes them unique. So we needed to add new fields to the tables to account for these new features. And it became a pain because you had to change it in the database, you had to change it in multiple layers of the software. There was a protocol that it was using to publish, it had to be changed there. So it was a problem for us, and it became a scratch your own itch scenario where we thought, if we could just store the sales to the local database and sync the data, just let the databases sync between each other, that would really make this a lot easier to add new fields. And if we're syncing in a real-time fashion, that would solve that end-of-day problem. You'd always have up-to-date sales information. And we also wanted to solve the problem of scalability. We already saw that problem coming. We were at 300 stores. We needed to go up to 1,200 and beyond. And we wanted to be able to have a cross-platform set of databases. At Central Office, we could pay for Oracle. It's an expensive licensed database there. But at the store, it was cost prohibitive. We wanted to use MySQL, an open source database there, and all the way down at the point of sale, we wanted to use an embedded database like H2 or Derby. So we wanted that cross-platform capability. Another feature or requirement was to handle a low bandwidth network. I mean, this is becoming less of a problem, but frequent outages were a problem, especially when you have that many deployments. You've constantly got a store that's offline, and you need that data synchronization to retry, automatically get through, guarantee, you sort of hands off. I really don't want to have to deal with it, right? It should be automatic. So that was the set of requirements of the problem, where it came from. And a group of us got together, and we really wanted to do this in an open fashion. We liked open source software. We'd been using it in IT. At the time, there was this whole off-the-shelf versus build mentality. There was a lot of off-the-shelf software being put in place. We weren't happy with the landscape of enterprise software. It was bloated. It was not well documented. The support from the vendor was lacking. You couldn't really customize it. So we really wanted to be flexible, pluggable. You can extend the software if you need to. And we wanted to leverage a bunch of other open source software. So that was where we were coming from with this problem. And so we solved it. We actually wrote software that did this cross-platform data sync, and the company that we were working for allowed us to open source our software. It turned into a project called SymmetricDS. So symmetricds.org is our project website. We're out on SourceForge and GitHub. Today we have a couple hundred downloads per day, 240,000 downloads over all time, thousands of open source users. We have commercial customers now, so there's a company, JumpMind. We now support SymmetricDS deployments. So we have customers around the world that we support with that. One of our largest customers is Dollar General. They have, I think they're up to like 18,000 stores, 6 registers per store. So it adds up to somewhere higher than 60,000 databases, all in one sync scenario being synced in real time. We now support more than 30 database dialects. In the beginning, it was Oracle and MySQL and I think Derby. Now we're on, we can support all kinds of relational databases. There's NoSQL databases, also cloud-based databases like Snowflake. So we've really expanded. And the way it's been architected, it's pretty easy to add another database. So someone will come along and they'll have another platform like a RAMA database or some obscure database, and we're like, give us a couple weeks and we'll get it working for you. So this is sort of a feature overview of what it is. We're talking about cross-platform database replication. It can actually do file sync replication as well, and it'll integrate with some of these other non-relational things. So you can publish to targets like Kafka, for example. But at the core, it's relational database replication. You can sync in one or both directions, and it's got a conflict manager built in. So if you're changing the same piece of data in two places, you can put rules in. The conflict manager will choose the newer piece of data as the winner. There's also streaming ETL capabilities. So on the fly, you can have transformation of data either on the source side or on the target side where it's loading. So you can augment the data. You can query from the local source or local target to get those transformations done. At the heart of this, it's change data capture, either through physical triggers in the database or through log mining or through change tracking. So the user has some options there. And another feature is the initial load. So to get into your initial sync, you'll request an initial load. It'll pick up all the schema from the source, all the data from the source, apply it to the target, and then that'll be followed by all the changes. So you'll get that consistency. You'll have that integrity of data in the end after an initial load. Here are some of the use cases. The top middle one is the one that I was describing in retail. They had that large central office database syncing with a store database, and then to a third tier, which is the point of sale register. So you can tier the nodes, you can tier who registers with who to sort of isolate them so that they can only see some of the nodes in the network that you want to replicate with. And then as our solution progressed, we started building out more types of scenarios, like a multi-primary where everybody stays in sync and you have conflict management. There's clustering support, so you can cluster a node to make it highly available. A lot of people are building data warehouses where they're consolidating multiple disparate data sources into a data lake or a data warehouse. We also have mobile support, so you can run on Android with SQLite database. So you have like a disconnected offline mode, also on iOS with a C-based client. So we're talking about this real-time integration of data out there in the industry. Some people are calling this streaming ETL. I just wanted to give you some perspective on you don't always need to have real-time integration. Sometimes the traditional ETL where you kill and fill is appropriate. It's simpler, right? But here's some times when it does make sense to go with the extra complexity, get the real-time integration. If it's core to the business, if it's critical business data, it probably does make sense to have that timely access. In e-commerce, I think it's probably expected by customers to have real-time access. I put my order in, I get the email back. So data integration needs to be in real time. If I call into customer support, they have the same information there. And any customer self-service for that matter, they expect to be able to have data integrations in real time. What we're seeing with businesses that we work with is it's creating a competitive advantage for them if they do real-time integrations. In retail, you'll see customer loyalty is pretty commonplace now, but in the beginning, retailers were setting that trend, and then everybody was copying. It would be you buy something at the store, and then you could instantly see it on your mobile phone. You could see accumulated points. You could email a receipt to yourself. Now, buy online, pick up in the stores is getting popular. So those are scenarios where you need this real-time data integration to work. So like Big Lots is one of the companies that are doing BOPUS right now. Live golf statistics, if you've ever watched a golf game from the PGA Tour, and they've got the statistics sent to their website, or you're on your mobile phone, you're following the game. There's a truck at the game, and they're tracking the ball and tracking all those statistics about the players in the game in real time. Or if you've been to maybe a theme park and you've gone on a ride and they take your photo, and then there's kiosks around the park and you can see your photos on there, or you can go to the website. That real-time integration, it's almost surprising when they first came out with it that it works so well. So that's something you see with Pixolve, what they're doing with the photo kiosks. And BioConnect is another good example where they have, if you've been to like Facebook or Google campuses, or maybe a data center where key card access, or you have to use a thumbprint or a retina scan, And all of that data is being accessed in real time so that you can see who's accessing what doors where at what time. So those are good examples of when it does make sense to use streaming ETL. So now I wanted to give you a demonstration. I'll go through this on command line. Josh is going to give you a little bit through a web console view. And a lot of this can be automated too if you want to script things. We're going to have a corp database running Postgres at the central database, and we're going to do kind of a retail scenario with multiple stores. I have 2 stores set up, but you would obviously just repeat this pattern. I'm going to show you how to do push and pull synchronization. That means the store is actually going to initiate all the communication. The store is often behind a firewall, so it has to initiate the communication. There's a registration that happens. That's when one of these database endpoints, we call it a node, it's going to register and join replication. I'll show you how that works. We're going to request an initial load. You can also configure it to have the initial load happen automatically. And there's also something called a partial load if you ever need to just partially send a table or just a specific table. I'll show you change data capture working. I'll give you an example of subsetting. So the first thing we have to do to set up a node, some people call it personalization. You create a properties file, and it goes into the engine's subdirective symmetric DS. You need a few properties. So first of all, you come up with a group. Everything is configured at a group level, and that's just to encourage reuse. So you might just have one node in the group, and that's fine. But the idea is you could have multiple nodes in the group, and you only have to configure them once. So I've got a corp group, and then you have an external ID, just a unique identifier. How do I know where it is? It's like a street number, or it's a location number. I'm just going to call mine 0. You have an engine name. This is just to refer to it quickly from the command line. So I'm just going to combine those 2 pieces together, corp 0, 0, 0. You have some properties here. So this is a Java-based server. It's going to use JDBC. So most databases have JDBC drivers. This is a Postgres driver that I'm using. That's the URL to get connected to the host of my database server and the database name, user, password. So then at the bottom, you have the registration URL. Who am I going to register with to join replication? And in the case of the corp node, it's the first node, so I'm going to leave the registration all blank. And everybody is going to register with the corp. And then I have to publish sort of my sync URL. Where can you reach this node in order to sync data with it? So I'm just going to use localhost, and the default port for symmetric DS is 31415. It syncs over HTTPS. I cheated and used HTTP here to keep it simple. But you'd want to secure it with HTTPS. And then this is the store node. It's very similar. I'm going to call that group store, and I'm going to do cross-platform. This is MySQL that I'm going to connect to. I don't need a sync URL because I'm not going to actually receive any communication from another node. I want these store nodes to do the push and the pull. So no sync URL is required in this case. Nobody's going to reach me. But I do need the registration URL to join replication, and so I give it the sync URL of that corp server. So I repeat that for store 2. And then I have to put some configuration in the database. So we started off with a simple properties file. Who are you? Which database are you connecting to? But then there's a lot more configuration that I can do, and we do that through the database. Symmetric creates a bunch of runtime tables, and they're prefixed with sim. You can change the prefix if you want, and there's also configuration tables in there. So one of the main ones is the node group table, so I have to put my corp and store entries in here to match up with my properties files. Here's where I configure the push and pull. So I use a table called symnode group link. And here I'm saying, hey, when I send data from corp to store, I want corp to wait for the pull from the store. That's how I express the pull. And then when I'm syncing from store to corp, I want to push in that direction. So you can see the little arrows are kind of showing you what's happening here. So that's how we get push-pull. You could do push-push if you wanted to. It's actually more efficient to push-push. Pull, you're actually polling. You're asking, hey, corp, do you have any data waiting for me? And it might say no. Come back later. So it's always using the network asking. If you don't have a firewall involved and you can push, it's only going to open the connection and push when it has data waiting to send. So that would be more efficient. And then I have to define which tables I'm interested in. You can actually use wildcards to specify the tables. You can list the table names separated by columns. You can exclude tables with an exclamation point. And there's also a configuration in there if you want to exclude certain columns, or if you want to filter certain rows, or even if you only care about inserts and updates and not deletes. So you have all kinds of options. We're using the table called SimTrigger, and you just give it an ID, and I usually just make the ID the same as the table name. So I've got sale transaction, I've got sale return line item. This is all retail data, item selling price. And then if you notice, I've got these SimTrigger entries are a little different. So what I'm showing you is how you can turn off the insert updates or deletes. So it's kind of weird to think about. Why wouldn't I want to capture those changes? Well, in some cases, you just need to send the data down for the initial load, and after that, you don't care about changes because it's not changed often or ever. Maybe it's something like a lookup table, or in this case, I'm sending down my sales transactions. This would be like, oh, the store server had a hardware problem and we're rebuilding it. We want to repopulate all the sales and sales transactions that the central office had. But central office doesn't change transactions. It's always changed at the store. Another concept here is the router. So I'm going to configure a router. It's configured on a group link. And I don't know if you guys have used this is just an interactive SQL tool. I've got my corp, I've got store 1 and store 2 that I'm connected to. And you can see on the corp database, I've got the item table, item selling price. You can see how these tables are populated. I've got some Yummy Gum in there. I'm selling it for 20 cents at store 1, 30 cents at store 2. And then I've got some sales transactions in here for store 1 and store 2. On the other hand, at the store, there's no tables whatsoever over there. So here is my Symmetric DS installation. If I look in the engines folder, oops, this is that properties file that we configured together. I've changed a few extra settings down here just to automatically register stores when they connect. I'm going to go ahead and run the server. It's just the sim command inside the bin folder. So it'll start up, it'll connect to Postgres. You'll see it creating all the objects that it needs, runtime objects, configuration tables. So at this point now, if I go back to dbeaver and I look in my list of tables at corp, so now I've got some sim tables in here. So there's a series of sim tables, like here's SimTrigger. Now SimTrigger's empty, right? So those are configuration tables that aren't populated yet, but the tables are there. So I've got the configuration that I took you through, so let me go in. And there's some command line utilities in here for manipulating data, db import, db export. So I'm going to use the db import command to insert my sample configuration. And what you'll see is the server is responding to that. So it's now installing triggers on those tables to start capturing that data. And you'll actually see that over here. There's my trigger configuration. Great. So now I'm going to bring up a store. I do that same way. I've already pre-configured these guys. So you'll see it'll go into my, oops. I'm going to run it with client. That way it won't try and put a web server on the port. That was the error there. So client, it's only going to do the push pulls. It's creating tables in MySQL here. And it's going to register with my corp server. You can see it installing triggers. So now if I go over to store one, you can see the same thing. There's my list of tables. I don't have the item, sale, transaction, those tables yet, but I do have my SIM tables. And if you look inside the SIM tables, the configuration is there. So it keeps its configuration in sync. It's sort of an eat your own dog food kind of situation. Let me bring on store two. Same problem. And then let's change some data so you can see some data moving around. I'm going to put in a new sales transaction, sale 101. Oh, I think I need to do an initial load first. All right, so my tables aren't there yet. So let me go back to corp. There's a utility called symadmin. It's got a lot of useful subcommands here. So one of them is to reload a node. So I forgot to send the initial load. I'm going to request a reload of node 1 and a reload of node 2. You'll see it's creating the sale transaction table. You can see it's installing triggers on it because we've asked for replication in that direction. And if I look in sale transaction, you can see that sale, just that one for store one is there. There's the Yummy Gum item. And then just the price for store one is in store one. So I'll send back transaction 101 to corp. And if you watch in the log, you'll see where it pushes data to corp, and it'll even tell you, hey, it was from the sale transaction table. Just an easy way to watch what's going on there. So now if I look in sale transaction, I've got 101 from store one, and then the associated line. And let me do a real quick in the other direction. Here's a new item. And I've got an item selling price for store one and store two. It's like 50 cents at store one, 60 cents at store two. Same thing, you'll see pull data being received at the store. And then let's double check that it's there. So some tasty cakes selling for 50 cents at store one. I only got the prices at store one that belong to us. So that's the subsetting. That's how change data capture is set up. Now we've seen the initial load. We've registered 3 nodes. That was all command line. Like I said, all kinds of features and customizations that you can do in there to automate these things. I will turn it over to Josh at this point to do an example with the web console.
Whoops. Sorry. Yeah, like Eric was saying, we've got a supported version on top. I'm going to go through all just stuff though that still is part of the. Oh, it's detecting. Hold on. It's still part of the open. We'll just wrap it with the web GUI. So if you do add the support layer, but we're going to go through only the open source kind of functionalities. With the supported version, you get a console, pretty standard stuff. You can kind of monitor things from a dashboard look. The first thing I wanted to do, if I can get my mouse here, is I've got a similar setup. I actually have all Postgres, so I've got a corp and a store, Postgres, similar kind of setup, and I'm in the design phase. So I actually am going to go through the same scenario of subsetting data. I could select the full table if I need to just, hey, I want all the data going everywhere. Just an easy sync. The full table is going to go. But in the subsetting concept, this is a little bit of redundant, but I want to show you both ways first. So here's the subsetting with the column again. So we got this data that we don't need the targets don't need the full set of data. So we can be selective on what amounts of data we want to send to those targets. It allows you to size and get things set up properly. So if I go in here, we're going to do real similar. What's the column that's key in all this? It's that store ID column, and it represents my external ID. So very similar scenario to what Eric had set up originally, just kind of showing you what the GUI side of it looks like. So I build that out. What tables do I want to pass through this concept? So let's say I had 15 tables that had a store ID. I can quickly go through and use the same configuration for all of them. So I'm going to go just take that item, or item selling price, sorry. So I just want that item selling price for now to move through that, and one direction or bidirectional, and boom. So that went through the same process that he just went through, got it all set up. I'll go out there and add the same. I got 3 nodes. So one thing we're going to add a little bit. I don't actually have this node yet. So I only have 2 connected, 1 and 2, and we're going to actually put some extra data in here for a 3, just in case it's out there at some point. And we'll use that a little bit later. So if I go ahead and run this guy, get that data in there. Now we can monitor this a little more through the GUI. So we'll have this data that passes through. And we've got, let's see here. I got my install triggers. Yeah. Oh, I didn't put it on item selling price, did I? Oh, I need item selling price. Let me get the item selling price in here. There we go. Okay, so let's actually, this will be a good test. We'll delete this again. Clear that out. Get that out of there. And we'll move it through again. Oh, I deleted it again, sorry. Live demo. All right, so now we got that in place. We should have there what we need, and then we can actually monitor. Yeah, so we've got this data going to node 1, node 2. It actually hasn't loaded yet, so we're kind of, this gives us a little indicator that hasn't, oh, now it just committed with the green. We actually had one that went unrouted, so that was that store 3, kind of letting you know, hey, you had some data here that was marked for a store 3, but it never actually processed because we don't actually have that store out live yet. So a good indicator it went unrouted. So that's, again, just a simple column match. Let's go through a little more complex scenario. So again, we're back to subsetting. Let's say it's not that simple. Let's say we have information that's more of a one-to-many. So I've got like in this case, we're going to do a concept of promotion. So again, back to retail use case. They would have something like a promotion, and maybe that promotion goes to multiple places. So it's not just one store for each promotion. It might be a many. So this is, the column match is kind of a one-to-one, and this is more like a one-to-many. So I have a table out here called promotion store, I can't type, xref. And I have a column on there. So what this is saying, I've got this xref table. So whatever promotions, I want to link to whatever stores are going to be in that table, and I'm joining them on that promotion ID. That's what creates the bind to those. And then this is going to be the store ID. So what this is saying, hey, when you find a match on a promotion ID, this is what stores I want it to go to. So we'll show you that with some real data. So I'm going to send that through, I'm going to send the promotion table through this lookup concept. So we move that guy over, select him, one direction. So now, if we go out here, get rid of that guy, select, let's just take a look at what's in here. Select star from promotion store xref. So my business rules say, hey, this store promotion ID 100, whatever that it might be, needs to go out to just store 1 and store 3. And this, imagine you got 1,000 stores, the business can drive all this. They can put it in the database, they can manage it. You can have an app sitting on top of it that drives all this, and Symmetric's just working at that data layer underneath. So whenever store 100 or promotion ID 100 comes in, this is the stores it's going to send to. So if I go out here and grab a quick BOGO promotion, buy one, get one is a popular retail term if you're in that space. So I'm going to insert 100 in here. And again, if I go out and monitor this guy, there comes those 2 promotions. So I see that I got the promotion table, new, and it moved it through. So now we can go out here and we can take a look and see that store 1 got his information. So there we go. So we can selectively move that data up, down, and all around. Let's look at one more thing here. So with Symmetric, there's a whole lot of parameters that have been put in place. The parameters kind of drive functionality. So there's often timeouts and tunings and settings and all that you can adjust. Let's look at just what we've been set for this setup. Now we've got some console stuff that I'm not worried about because that's kind of pro. The big one I want to show you guys here is the auto reload is set to true. So this means anytime a new node comes on the sync scenario, I want it to automatically receive a full set of data. So whatever's been configured, it's going to at that point come online, receive its full set of data. Because you have to have that initial sync in order to stay in sync with changes down the road. So the initial load, we're going to turn this auto reload on automatically, so every new node that comes on, automatically sending its full load of data. It's still going to go through that column router, subsetting, any rules you have in place. And the other thing is we're going to initial load create first. So this means I don't have any tables. I could turn up an empty database, connect with that engine property file that Eric showed. It's going to connect in, it's going to automatically create the tables, and it's going to send them full of data, and you're all live and syncing. So you can start with a completely empty database as you roll out, and all you need is that engine file. So let's go through. Let's see here. So I'll go out to the dashboard, and again, we're going to connect another database. So I'm going to connect, in this case, I'm going to connect local because I'm just working off a laptop. In a remote scenario, this might be a node out in the field. Maybe you're connecting geographic locations, east, west, different stores, we do a lot of office sync, we do a lot of maritime stuff, so ships at sea, because they're in and out of network connections, so they're moving around, and that stability of the network going up and down and not having to deal with the network connection being up and down is a huge. So in that case, we would have done a remote setup, but in this case, laptop, I'm just all local here, so it's just going to be a local sync. So these are all those databases that we talk about, lot in the list here. You'll see, let's say if I go through, if I just pick an example, right now, everything popular, Snowflake's popular. So we can actually set that up as a load only. So some of these cloud-based ones, we're only loading data to it. We can set up a smaller footprint and just set it up as a target. We're just going to load information to it. So you might have deltas coming out of Oracle, SQL Server, whatever, but I only need to load data into Redshift or Snowflake. And it's pretty typical for some of these cloud setups. Let's say I go, and I'm going to actually set up another Postgres. So in Postgres, we have several options. We've got the trigger-based approach, which Eric showed. We actually have log-based approach for some of these. Trigger-based when we created this 15 years ago, the trigger-based approach was kind of a standard across. You had that option. Log-based is becoming more popular. Obviously, different vendors have supported logging in different ways. So we're adding to the arsenal as we go, but we do have it for a lot of the bigger platforms. Again, you can always select load only. Extract only is really not too popular. It basically means you're going to custom lift and shift kind of concept. I'm not going to do any capture really. I'm just going to select and move data on my own. Not as powerful. Sometimes it's used when you don't have access. You're accessing a database that really isn't yours. You're not allowed to manipulate. You can't get to the logs. But it's out there. Not as popular. It's a little harder to kind of set up. So let's go ahead. I'm just going to do another trigger-based node, Postgres, my Postgres database. I just created one called Store3 that I already have out there. we got everything we need. That's that registration URL. It was part of that engine file. A lot of this is that engine file. So with that open source engine property file, we're just looking through, visually seeing what pieces. This is that store group. So this says, hey, I want this node to behave like every other store. We're not going to change a thing. Whatever every store is doing, all stores are doing. So this is that group. And then we're just going to give it a name. So let's call it 003. This matches my data in the database. When I was doing the subsetting and all that, I had my store ID set to this 0. So this is your way to alias. If you have 5-digit codes, a location name, if you have some kind of scheme mechanism for naming your devices. If it's Android devices, sometimes they have unique IDs that are set to every device. This is where you put in that kind of piece of information. It's the external ID in the engine file. And then we got the sync URL. So this is just the endpoint that this node syncs on. And clustering we don't need. So it's going to go ahead and get that guy going. So what that did, we can go out here to outgoing loads, and pretty shortly here we'll see this guy will kick up a load. I can always go back over here and check the same logging. I don't have my filtering set up, so we won't do that right now. So I've got an outgoing load. So this tells me, hey, I got node 3. He automatically came in to register. He's getting his load right now because I set those parameters to say, hey, when this guy comes online, automatically send him a data set, create his tables, and go through everything. So I can go down and check the details in this. All of this is statistics is available in the open source tables and stuff that just bring in a GUI to it so you can kind of visualize it instead of looking at a lot of text for right now. So this just gives me the whole rundown of the load. What did I request? What was my request for this load? You can create all kinds of requests. You can insert SQL statements to generate these requests. Let's say you had a node that got corrupted. You need to redo it. You can insert one line that says, I want to request whatever it is here that you're looking for. It'll automatically, it's got a background job that's going to kick it off and issue that. So there we got our workflow. How long did it take? Not anything real exciting, couple rows of data. We've got our item, our promotion, our selling price, all run through those different routing rules that we set up. And you'll see in a bigger set of data, let's say you got a couple hundred tables, pending to active to completed. It's threaded out, so you're going to see it working on extract, transfer, load kind of concepts. This is more ETL, kind of similar approach, but it's just that lift and send the initial set. The nice thing is once this node is connected, it's set up for change capture. So while this load is running, if changes are coming in, Symmetric is smart enough to hold those changes, let the whole load proceed. When the load passes and finishes, then all the changes are allowed in. So your users never have to be turned out of the system. They can be live the whole time. It has a channeling mechanism that is behind the scenes. And that reload, it's smart enough to know this is a reload processing. So we're going to capture data. We're just not going to transmit it until that load's completely finished. So that's kind of the advantage there of that load process. So let's look at one more thing. I had a transform. So transforms are a big part of data now. Let's say, I don't have a lot of room on this podium. We'll work it. Let's say we need to transform data. So you can transform two ways. You can transform schema, so you can transform structurally what tables look like. I always give a simple example. Maybe you're taking old system, new system. You don't like the way the columns are set up. Maybe they had a first name, last name, and you're going to consolidate to a single name. So that you can consolidate structurally wise. You can also transform data itself. Pretty common now in today's space. The nice thing is this all happens as part of the replication. So it's live transformations. As CDC is occurring, the transformations are firing if they apply to the table. So let's go ahead and we'll auto-create a couple of transforms. I'm going to create it on that, let's see. I'm going to go the other direction. I'm going to actually transform data for a transaction coming up. So ideally, as a store is ringing a sale, let's say I want to go ahead and capture, I created at Central an extra column called last sync time. So let's say at the Central database, I want to kind of keep a record of when this data actually came in. Maybe you have it last updated by or whatever, but I want an actual when it replicated time. So just as an example, let's take that sales return line item transaction table and actually, hold on. Let's go a little more. Let's do both of them. So I'm gonna put it on both of these guys. So I'm gonna go from store, and I want both of these. Implied is gonna be a big deal because it's gonna say whatever columns I don't provide you, just make a copy. So I'm gonna define this transform for just that last sync time. All other columns, just send them over as they are, untouched, just a straight copy. So let's go ahead now, and we can go in and let's get down to the column level. So we got these two tables transforming. I want to add a new column. A lot of built-in transforms, so you can do a lot of out of the box. These are all extendable. So if you have something here that doesn't work, you can write your own little extension point, add your own transform. We have a lot of businesses that will have custom business transforms that are specific to their business they can hook in real quick. I'm just going to do a quick variable transform for this guy. He doesn't actually exist on the target. So this is a column that only resides in the central. So he doesn't, I'm going to leave source empty because he doesn't even reside on that side. So, where'd my window go? So when transform on all, it doesn't, I can do insert, update, or delete, but I want everything. So anytime any manipulation happens, let's add this last sync time. Oh, zoom in. And it's just a system timestamp variable, so nothing fancy here. So just gonna apply a quick timestamp, save and close. So that's all set up. If you notice, I did this on the configuration, or the corp node. So we even sync, like Eric said, we sync our configuration. So any changes I make centrally, it's sent out to all the registered nodes so they immediately know what to do. So I can still manage everything centrally. We sync those configuration changes. Now even all the stores know, hey, I gotta do this extra work. I gotta run through this transform when data comes through. So let's go ahead and take a little piece of data. And I've got this is just a sale will ring on store 1. And I didn't have dbVerse. Symmetric actually has a built-in JDBC little GUI. You don't have to replace what you got, but it's a nice little handy tool. It's good for connections and permissions if you need to check something live that uses a symmetric connection. So let's just go ahead and run this sales transaction and a line item through. And we can flip over now, and this time we'll see it on the incoming batches. So this is data coming into Corp. So there's our sales transaction and sales return. 2 rows came in. They're good to go. They came in from node 1. Let's take a quick look on Corp. And verify that we got that last sync time there it is. So, yep, 4:28, right on time. So that just kind of shows how you can do the live transformation. So a little bit of subsetting, a little bit of live transformation. Real quick with the minute or two we got, there's a whole bunch of other pieces in here, extensions, so it's very extendable, developer friendly, so you can add extension points, customizations if they don't have what you need. There's a whole bunch of custom jobs. So these are out of the box jobs Symmetric's running. You could go ahead and create your own job. And we got Java, SQL, Bean Shell. So you can go ahead, hey, I need to run something every night at midnight, and you can put this on a schedule. And it's a little more advanced. Maybe it does some extra work, or it plugs in and does some extra hooks. So it has a lot of customizations between the jobs extensions and even these load filters. The load filters can run, and you can apply scripts before it writes the data, after it writes the data, when the batch is complete, when the batch is committed, if it rolled back. So you have a lot of different hook-in points for customizations to reach out, maybe either notify a team member. We have monitors and notifications built into the Pro, but if you need to hook into something that you have on your own, there's a lot of different things you could do here, right to an audit table if something failed and you want to kind of preserve that, come back and look at it later. So there's a lot of hooks. We built it in mind with developers and knowing that we had to use this stuff at real client projects and we needed these hooks in place, so that's why a lot of them are there. So we're right at the time, pretty close, right? 4:30, is that our questions or anything? Or that's really it. I mean, it's out there, symmetricds.org. Been in a lot of, yeah, hit it.
Are there, is there an ability to alert or to replay things like if something goes wrong?
So if it doesn't commit, it will sit in a pending state. So it won't actually commit anything. It will keep trying. Let's say it did commit, you can always initially load. So I can always go back through and do even a partial load there's not like a true rollback concept. And Eric, jump in here if you want. The load data, though, I could go in here and say, store one, you know what? I got a problem with my item table. There was something that got hosed up, and I can provide an actual where clause, and I can get very specific. Hey, I need to send this reload. Inserts fall back to updates, updates fall back to inserts, so you can safely resend this. So if I resend the insert, it runs into collision on PK, it'll fall back to an update to keep it just naturally moving and in sync again. If you run an update and it's not there, it's going to fall back to an insert just to get, this is the data I requested, it should be there. So, and you can do before. So if I go back here, I can also say, what do I want to happen before that data is sent? I can truncate, I can purge. So I could just say, hey, this table's hosed on store one. Let's run a purge or a truncate, clean it out, run a full set of reload data. So that's kind of a little more evasive. We don't have a true rollback. You can load that load filter that says on a rollback, what do I want to do? So we kind of have to talk through what do you want to happen, on those scenarios. You have some hooks in place, but you have to kind of still define what do you want to happen. What's that? So yeah, great question. With the triggers, you got an additional insert. So with the triggers, it's capturing and running into one of our runtime tables. So we push those runtime tables, we maintain them. It varies per database. So like Postgres, those runtime tables have to exist in the same database that you're syncing because you can't a trigger can't write to another database, but SQL Server you can. So SQL Server, you have a little more flexibility. You can say, I want to replicate database A, but my SIM tables reside in symmetric database. So they're away from your application. They're going to incur an extra insert. I can tell you our largest vendor, our largest customer, T-Mobile Sprint, they're doing about 20 million transactions an hour on the trigger-based. So they're doing all their all their corporate sales information goes through. It's all hidden trigger-based, and they are hot and heavy. I mean, if they have an outage, we got to get on it right away just because it backs, it backs up fast. But it stays. We've got a white paper out there on it, so it does incur that extra insert. Obviously, if you're log-based, not as much. You still have to turn on whatever the logging takes from your system. Whatever Oracle resources are needed for logging to be turned on, and the wall log and the write ahead, the bin log for MySQL. So whatever that extra incurs on the database, then we're just using the log. So I will say it really hasn't been an issue. We do some pretty high volume. And we maintain those triggers. There's a trigger hiss concept that we didn't get into. It hash codes everything. It knows exactly what those should look like, what the table structure looks like. So we know if that table changed and columns are added, that hash won't line up. We'll rebuild that trigger and make it whole again. Did you have? No. I wasn't sure if okay. Does that kind of hit? Yeah. So to be honest, it's an additional insert. Yeah, but that. If you're doing trickle changes or some kind of control changes, it's not bad. And the initial load is just a select, so you're just pulling data out on the initial load. So usually, once you get that load process in place, and on the pro side or the commercial side, there's a bunch of bulk loaders. So then we leverage, tools that the vendor provides for PG copy and things like that we'll wrap in. And a lot of the cloud ones will do different bulk loading so that you can get the data in the target faster. And then really, once you get the data synced in that initial load, the change capture really, it's really reliable. We've been doing this for 15 years. It's all over the globe. I mean, it's running in a lot of places. It's very well battle tested. It's running in departments, U.S. government. It's running cruise lines. It's running casinos. It's running all over. Major League ballparks. So, any other questions? We just kind of focused on the retail use case today since we're in the use case room. So we thought I would give that case study, but there's a lot of case studies we hit. So yeah, look it up. If you want any flyers, I got a little handout that's got just some of the, restate some of the stuff in the .org site, and it's got even our emails on it. If if you ever want to email us with questions and stuff, we love talking with stuff. So cool. I don't get anything else? No? All right, happy hour. Thanks, guys.